Hey, okay. Hello, sorry about that. Thank you. Okay, taming the React Native monolith with module federation. So this is quite a broad topic, but also very niche at the same time. So we spent a lot of time thinking about this at the place I work called OVO, which is an energy company. And it's a very big problem, very big solution to solve quite a little problem, which is, yeah. So who am I? I'm Tom. You can find all of my links on that website. I'm a software engineer. I mostly do front-end stuff. And I work on a front-end platform team called Core UI at OVO. So we do kind of like design systems. We do front-end tooling for other product teams. And yeah, that's me. So OVO, this is kind of important for the context of the talk, just of how we got here and what we're doing. We're an energy company, and we have a React Native app that we hope, we want to turn it into more than just somewhere where you can go and see how much money we're taking from you, essentially. So somewhere you can actually do cool things like look at your solar panels or be more engaged. So that's us, and we have like distributed teams. This is like a big thing at OVO, but it's not been something that we've done on the front end before, having multiple teams really, which I can get into in a little bit. So another thing about us is that we love React and we love React Native, and that's mostly because of the web and how there's so much crossover there. And it's just so great, especially for recruitment. Like none of us who work on the native app at OVO had done native development before, and React has been like a gateway into it, I guess. So native apps are difficult. So if you've worked on just the web, which was me before I started doing this, there are a bunch of problems that come up there that don't exist on the web. And as a front-end developer, this is like maybe the first time you've been introduced to these problems. So one of them is that you don't wholly own your deployments. So when you want to make a change, you have to kind of ask Google and Apple very nicely to deploy your code, basically. You give them the code and they'll give it to your users. And they can say no sometimes, which is very annoying. And then the other problem is those releases exist forever. You can't roll one back. Or if you ask Apple very nicely, they will do it, but like they hate you if you ask them. And if you ship a bug, it's out there forever. You can't do anything about it, so you have to be really careful. And this is kind of like an outlandish idea if you're a web developer, where you can just push new JavaScript and that will just get into the browsers. So what can we do about that? Well, first, we need to just talk about how React Native works before we can figure out a solution. So React Native works with this kind of two-layered architecture. We've got kind of native code, which interacts with the operating system, and then we have JavaScript kind of within it, and they interact over like a bridge. And what that means is most of the code that you write will actually be JavaScript. That's why it's like React Native, because most of the code you write is just in regular, plain old React. And it's great because you can then just swap out that bit around the edge, which React Native kind of manages for you, and deploy it to multiple platforms like iOS and Android. When you're inside of that JavaScript bundle, it's actually shockingly similar to a web app, which is really great. But we have that same problem where you have to deploy it to the app stores. So what can we do? Well, one thing we can do is this concept of over-the-air updates. So if you remember that diagram from just the previous slide, that piece in the middle, that JavaScript piece, we can download that over the air, exactly how a web browser would in our website, and kind of swap it out for the user themselves without having to go through the app review process on the Apple and Google Play stores. So thus we use a technology called Code Push, which is a free thing that Microsoft offer, and it allows you to get updates essentially over the air, bypassing the App Store, which is really good for solving that problem where we ship bugs essentially and we want to get rid of them. So this is kind of what it looks like. We download, we connect to Microsoft from everybody's apps, and we download new updates. We can do some cool things like download them in the background or whatever and apply them on the next restart, which is quite nice. But like, there are still problems with this that we wanted to get around, essentially. So problems with this architecture is that you have to build and test the whole thing every time. So this is the same as before if you were writing any other native app. And that can become slow, right? If you have a lot of code with a lot of teams making loads of changes, it's complicated to try and speed that up. And then the other problem is that ownership among those teams is blurry, and there's no real black and white lines to like separate all of the different parts of the app. And then one of the bigger problems that we have is that the user has to download it all every release. So even if we change a tiny bit of copy and we want to kind of push that out via code push, you have to download the rest of that. It's pretty stupid, really. And then large sweeping changes are like really hard. So as the team that works on the design system, when we want to roll out a new version of that design system, we have to get all of the teams in their respective places in the app to update all at once. It's essentially one pull request, which is like pretty good for kind of design consistency. Designers are pretty happy about that, but like we hate it because it takes ages and is difficult. And then lastly, deployments are centralized. So this is another thing that we hate in the the platform team, is that we have to do the work for the other teams, which we would prefer not to do. And it links into this thing that we have at OVO called, or that many companies have, called ownership and autonomy, where teams can essentially own their deployments, and it's kind of their responsibility to make sure it gets into production the right way. Adding extra people in the steps in the middle there is where errors can happen, right? So it's a monolith, right? This is a buzzword, but like it's the same problems that you would have in a massive back-end server with loads of, it's got too many concerns, and we want to split it out, basically. So microservices is a thing that we would do on the back end. I think this is kind of a very, like, we collectively know what that means, I think. It's kind of like we have many services doing specific things and they all interact with each other somehow. But this idea of micro frontends maybe is a bit more nebulous. So we want to kind of do the same thing, where we kind of split up our app into micro apps, I guess. But we need new ways to do this, right? So when we talk about micro frontends here, we're not talking about kind of multiple frameworks on the same page, which is maybe what you've seen with micro frontends before, or multiple frameworks for the same root. This is actually micro frontends at maybe the import level in your module graph. And we can go on to that in a little bit more detail in a second. But instead of having kind of whole screens or whole kind of collections of roots, we have each import in your application to a module can be a separate build by a separate team somewhere else. So just talk about how we can do that. We have to talk about Webpack. So Webpack is a bundler for the web, right? And I imagine a lot of people in this room are already using it. It's one of many bundlers, but it's the one we're going to talk about today because it's the one that actually enables module federation. And specifically today, I think it's useful to talk about Webpack as a graph, or like a way to bundle up the graph of your code that exists on your hard drive into a single deployable unit. So here we have like a very simple app that I wish our app was this kind of simple of a graph, right? And we have kind of like modules importing each other. So on the left-hand side, we've got an app.js that imports our navbar and our router, and the router in turn imports these two screens. And then both of those two screens import the same button component, which is like it comes from the design system, for example. So that's what Webpack does. It allows us to draw that dotted line around the outside to kind of smush it all into one unit. On the web, we can do cool things like code splitting, and this is something we can actually do on native, which I'll come on to in a second. But still, even with code splitting, without module federation, you still have to build everything at the same time. It's still a monolith. You're just kind of deploying it as multiple bits. You still have to develop it as one single application, right? So module federation is a feature of Webpack in version 5, which is the most recent version, I believe. And it enables many Webpack builds to act as one. So instead of having essentially one dotted line around that whole thing, we can maybe split that up into many boxes. So federation is an interesting term, right? So if maybe a regular Webpack app is Twitter, maybe our module federated app is like Mastodon or something, and maybe that's appealing to some people in the room, or maybe you hate it. So this is what it kind of looks like, where we have multiple Webpack bundles now. We have multiple Webpack builds, so multiple of those dotted lines. And each of these are actually owned by different teams. They're in separate like Git repos. They don't even need to be in Git, actually. Like, we don't care. But the code that the user runs on their device is actually exactly the same. So each of these arrows that goes across a line, that's what we call a federated import. And these are what you would usually do as like your code split points or your lazy loaded points in a regular Webpack app. But here we're just kind of we're going to a completely separate build. And that enables us to run the build faster because there's like simply less to run. Like in each one of those boxes, there's less code to worry about. And it allows us to test it faster, and it enables focus, right, within that box. So how do we bring this to React Native, right? Because we're talking about web stuff. This is Webpack. Isn't that for the web? Well, obviously I wouldn't be doing the talk if it was. So what we need to think about here is the heart of React Native app is that JavaScript bundle. And we already have a bundler in React Native called Metro, which is actually very good, but it doesn't allow us to do this splitting that we want to do of module federation. So we need to kind of put it in the bin, which is what that emoji is signifying, and get something else, which is Repack. So there's not really much to say about Repack. It's just a way to run Webpack in React Native. That's what the re part is at the beginning. And we've been using this in production for a while, and it works really well. So code, I have no idea if that's big enough for you to see, but it's showing a Webpack plugin. And so this is what you would define in your app, in one of those boxes as a team deploying into this system. You would add this to your Webpack configuration. And in the top, we can kind of declare what our app is, like the name of it, so that's what that name and file name is. And then the next part is this part called exposes. And this is a way to essentially declare to the world, these are the things that we are exposing to you. So if I was another team, I could import these. As federated modules, right? So as kind of when the app starts up, it can grab the refunds and direct debit screen and render those to the users. And then moving down, we've got this idea of remotes, and this is our dependencies for this module. So here, our app depends on the design system. It's essentially the same as what you would see in a package.json dependencies, where we have a name, and then in a package.json we'd have a version, and we do have that here, which I'll touch on in the next slide, and we have a URL. So it's an interesting idea here because we have the same semantics as NPM, so we have semantic versioning, major, minor, and patch versions, but it's all resolving at runtime, and that offers us some interesting capabilities. And then finally at the bottom, there's this shared part, which is a way to have shared dependencies across your federated app. So for example, React, we cannot have multiple versions of that in the app. React does not like that. And then React Native, and maybe if you've got some native module, like you're rendering SVGs or something, that has to be instantiated once throughout the whole app, because there is only one kind of blob of native code it needs to talk to. If it instantiates twice, then it's not going to work. So we need this idea of shared, and that's what that allows us to do. So one thing to note here is that in our remotes, they are like statically declared. And this is like great for tooling, because you can kind of run some tooling across this config and kind of generate some TypeScript types or something like that. But that doesn't have to be the case. Like you can omit this part of remotes here, and you can actually do like full dynamic in your imports, essentially, where you kind of put that URL into your imports and do it dynamically. So I mentioned versioning before, and so this is an interesting feature that we have here, where every import of a federated module is versioned. So if you imagine this as kind of an NPM package, we've got two NPM packages here, right? Payments and usage, and they both depend on the same dependency of button. Think about the author of that button.js package. When they publish a new update, they're going to have to bump their version up, and payments and usage, they're going to have to go to the teams that to manage those and get them to update. Which is like, it's okay if you've got one or two, but then if you're a team which is depended on by loads of other teams, that can be a real big problem. So what module federation allows us to do here is essentially resolve those versions at runtime. So here we've got the payments module depending on version 2 of button, and usage depending on version 1, and that allows us to do breaking changes as well, but at the pace of the teams which are doing the importing. So this is really cool, because if you own the button.js, which is what we do in our team, we can propagate that out to all of the app automatically if it's a non-breaking change. And then if it's a breaking change, teams can update in their own time. And we enable this with like an inbuilt service that we've created. It's like a combination of NPM and like a CDN of code. And if you're interested in that, I'll speak about it afterwards. So another concept that we need to introduce here is this concept of a shell app. And this is like really common in module federated apps. It's a way to kind of have a single entry point that's kind of known, where all of the like dynamic stuff can be registered, and you have like it's much easier to reason about then, and it also matches the way in which people build these systems. You usually have one shared platform team that all of the other teams can kind of interact with to get their modules in the app. And it gives us a nice way to bootstrap the app, of course, and also where we can register those hooks across the bridge to the native SDKs. So as well as that, it's also our migration strategy. So right now we have this big monolithic app, And what the shell app can be is it can start life as that monolithic app. And as we separate things out, we federate them, and teams start moving their code into separate repositories, things could just start federating, and it can just be this gradual process. We don't have to do it all at once. So, okay, this is what it would look like in practice. Maybe a first pass of what you would do in practice. So, this is the home screen. And in this scenario, we have these two federated modules of this action cards component, which is like it tells you what you need to do next as a user. Like you need to submit your meter read, for example. And that's managed by one team. And then below that, we've got a summary of your energy usage, which is managed by a completely different team. And the first thing that we may jump to for implementation here is React.lazy, which is this way to kind of like dynamically import code, right? And I think that's natural, but it like gets you into this scenario where you have like loads of spinners, and it's like we don't want to add spinners everywhere we do a federated imports. We want to design those intentionally, right? But this is something that is possible, and maybe in some scenarios you do want to do this because you're happy for those things to load in when they are ready. And this is like what it would look like in code. You would wrap it in like a suspense boundary, and each one has a separate spinner. But like here we've got like too many spinners and many loading states that can cause jank and stuff. It's not ideal. And sorry, yeah, that's just showing them loading in. So one thing we can do is we can like wrap them in a single spinner. So that's one solution. I feel like that's a duplicated slide. Another thing we can do is preload the modules on the previous screen. So if we're pretty sure that a user is going to go somewhere else, which we are with the home screen, like we know they're going to land there, we can preload them. That's one option we can do. But we're still going to see those spinners if the user goes there too quickly. So what module federation allows us to do is kind of a new, this is not something you can do with code splitting in regular Webpack, is actually synchronously import your components. And we can actually mix those with local imports too. So you can see here we're importing our navbar locally. Well, you may not be able to see that because it's just got the // but there's a / there that says the navbar is local, like a local module. And then we're importing these two federated modules, and they're all synchronous. And that means that wherever we're importing these, we'll wait until they're all downloaded. And we can lazily load the home screen instead. So that allows us to simplify our loading story, but it also allows us to import things which we can only import synchronously. For example, React hooks. Like you can't import those asynchronously. So we can essentially federate anything here. So coupling. This is an interesting challenge that you come across in a system where you start to distribute it, essentially. And I don't think it's a common, it's not a problem that rears its head a lot in front end, because we're usually deploying in these monolithic architectures, and it's actually maybe sometimes a good thing to have things coupled together because it allows us to make changes quickly. But what we're doing here is moving to a distributed system, and in distributed systems that we need to reduce coupling, otherwise we're going to tie ourselves in knots. So yeah, that's something we need to avoid. Sorry, I was just checking if we had another slide for this, and we do. So what we can do here is we need to maybe come up with some new solutions, but also steal some old solutions that we use on the back end. So we can replace fetching data that we'd usually do in Redux, for example, and we can do that with React Query that has this kind of transparent data cache across federated modules. Another thing we can do is maybe replace our global shared state with some sort of event bus, which is similar to what we do on the back end. but like we don't actually have the answers to these yet. They're not. We're still figuring them out, basically. Some things that we do, like the data fetching, but then other things like this is all new to us. So maybe if you have the solution, please let me know. So let's talk about continuous delivery. So with code push, when we do deployments, we have 3 things which can help us, which are listed here. Like the first thing we can do is we can gradually roll out that code push, which feels like a nice thing to do, but we only need to do that because it's like such a big and risky deployment. If we had smaller deployments, maybe we wouldn't need to do a rollout. We can also do rollbacks and disabling of deployments, which is like we have a big bug in a release, we can just kind of roll it back, or we can disable it so no new users get that update. And another thing is we have environments, so we have like non-prod and prod. In Module Federation, we don't have any of those things by default, because what we're doing is resolving new versions at runtime. As soon as they're released, we don't have any concept of these gradual rollouts or rollbacks. So we can replace them all with different things. So gradual rollouts we replace with feature flags. So teams can manage rollouts themselves in this way. We can decide to import a different version of a federated module using a feature flag, or internally within that module, a team can enable and disable new features. Rollbacks are handled in the kind of traditional way you would do in like a library on NPM or something. You would just fix forward with a new patch, and that will get automatically downloaded into the places where it needs to be, where it's imported. And then environments we can handle with things like pre-release and version tags. So that kind of concludes the technical section. That's kind of the problems that we've come up against, and some of them we have answers to, some of them we don't. But I just wanted to like kind of end on the bigger picture, I guess. Kind of talk about maybe more of the organizational problems that we're trying to solve here. And so I wanted to try and tell a story, although I'm not a very good storyteller, and I've not told this story before, so this is going to go great. So before we became the front-end platform team, we were the app team. So we were a single team which owned the app. We owned the delivery, we owned all the features. But because we were like the app team, and every product person in the business and every single person saw us as the app team, we had to keep adding more and more features into our team, right? So every time a feature was added to the app, that also came to our team. Even when there was actual separate domains for these new features, for example, some sort of solar panel thing, for example, we would have to do the work to get that in the app. And it just simply wasn't scalable for us. We couldn't focus on that many things all at once. There were just too many priorities. So Conway's law, I think, explains why this is a thing. And I'm going to try and not read that. And I'm going to try and summarize it. I'm just going to let you read that while I take a drink. So this idea of code copying your organizational structure, I think it explains what happened to us, or how it happened. So because everybody saw the app as a monolith, that meant there had to be this single team which owned the whole app. And when we decided to move to being a platform team, we knew that if everybody kept thinking of us like that, we'd have a bad time, right? It's not going to work. And we also knew it made sense to make the system more distributed, because that's how we work in other areas of the business. So that's something that we wanted to do, but as a front-end platform team, we don't have the authority or power to do that thing in a large organization, right? This is a very complicated thing. You have to create new teams. You have to convince people it's worth doing. It's quite hard. And we just couldn't do that ourselves. But I think what can come to the rescue here is this idea of an inverse Conway maneuver, which I just think is like such a cool name for something. It's great. So it's this idea of like inverting Conway's law. So instead of having your code follow your organization structure, you have your organization structure follow the systems which you put in place in your code. So we can create this architecture of that uses module federation that where by default to get something new into the app, you spin up something yourselves and then you kind of federate it in. And that kind of then that allows people to think about the app in that specific way, right? It informs their decision making. And now it's like intuitive for everyone now that the app, the one that like customers install, is made up of many distinct products. Hopefully not for the user, but like for people inside of the organization, like it's many distinct things that are all packaged up into one thing. So now this way, no single front-end team kind of gets shunted with features that are just like it's way too many and it's like not possible for them to maintain anymore. Kind of new features can be kind of created more quickly by like forming new teams around them. And this kind of creates focus. And I think it's going pretty well. So yeah, thank you.